If you want to succeed as a programmer, you should change the fundamental way of your thinking. Imagine that you're trying to change the addition in your operating system. Now, let's assume that you succeed to decrease the runtime of this function for about 1 nanosecond. This is nothing important, right? If you create a program that has 3 loops with 10,000 iterations each one and 5 additions, the actual number of additions is 10,000 powered by 3 multiplied by 5. So here we have this number of additions. In this particular program, we can save approximately 5,000 seconds, which is about 83 minutes. In other words, very important optimization in our program. So let's try to turn on the switch of dynamic programming. Let's try to craft our way of thinking from a simple primary school problem. Suppose there are 5 apples in the basket and we add 2 more. Obviously, we will finally have 7 apples. But how can you be sure about the result without counting it? There are 5 apples and we put 2 more, so 5 plus 2 is equal to 7. But in this case, you don't count the apples, you just add them and tell the answer, right? I'm right now focusing on the counting itself. But counting from 0 is not necessary when we already know the previous number of apples. This is just waste of time. Here we can optimize by using memory and more specifically by adding the previous number instead of just counting from 0. Suppose that you want to find the best movie in each genre, like action, animation, adventure. First, the computer will collect data and based on a function, it will evaluate every movie. In the case that you want to go a step further and find out the best movie, there are 2 ways. The first one is to compare all movies on every genre on the same criteria, and the second is to keep memory of the 3 movies that are the best in every category and compare only them. The idea here is to reduce computational time and overall optimize our programs by using already available results. Same way can be applied to find out the longest river in the world, if we already have a list of the longest river in each country. Find out a solution more efficiently using previously obtained results is called dynamic programming in computer science. First, we divide problems into smaller ones by finding patterns and similarities. The goal here is to solve a unique problem only once and use it to obtain big problem solutions. Dynamic programming eliminates repetitive tasks in order to get the faster solution. If we find patterns into sub-problems of a given problem, we can apply dynamic programming. Let's try a mathematical example. Can we use dynamic programming to find out factorial of any number? First of all, factorial is the multiplication of any number from 1 to the particular number, and it is denoted by exclamation mark. The simplest method to program, or else brute force method, for calculating all the factorials up to a given number is to calculate each factorial and add to the list, like factorial 5, factorial 6. But what about a dynamic programming approach? First, we need to find the pattern that will allow us to use these techniques between the sub-problems. To find the factorial up to n, you should calculate the factorial of n minus 1 and then multiply it by n. Factorial 6 is equal to 6 by factorial 5. Now the important part for this implementation of dynamic programming is to save the information for further use. We will create an array in which every cell will save the factorial of a number. For example, the first cell has the number 1, then the number 2 and the number 6. So to find the factorial of 4, we just need to multiply 4 with the previous cell, the number 6, and we will have the number 24. In this way, we eliminate repetitive calculations.